Pre-Calculus, Chapter 4, Lesson 5, and we're going to wrap this up by covering a couple types of problem-solving things that we'll have you do in this lesson in addition to the functions that we've been looking at, or the graphs of those functions. And that is to solve an equation like this for x in a given interval. Remember, these secant functions, all of the trigonometric functions, have two places where these values could be true. As this value moves around the circle, there's two places where you can have a positive cosine, you remember, in quadrants 1 and 4. There's two places where you can have positive sine values in quadrants 1 and 2. There's two places where you can have negative tangent values in quadrants 2 and 4. So whenever you're given an equation like this, where the secant of x is equal to 2, well, there's actually two possible places that could be. And so in many cases, we'll give you the interval where we want you to solve this. So you'll need to look at the interval, and then in that interval, draw your reference triangle and simply put the values in. Okay, so for this instance, if we want an x value that's between 0 and 2 pi, that means my reference triangle has to be in quadrant 1, because that's between 0 and 2 pi. I then simply, actually this wouldn't be theta here, they actually use the x value here, so we're solving for x. What is x that has this secant value? The secant value, you remember, is the reciprocal of the cosine. Cosine is adjacent over hypotenuse, so this would be hypotenuse over adjacent, so this is 2 over 1, so I should recognize these two values as a 30, 60, 90, so this angle here is a 60 degree because this is over here. Now the other thing you want to notice here is if this angle measurement is in radians, your answer must be in radians. If this is in degrees, then your answer must be in degrees, because this is the interval that you're in. So this is a 60 degree angle, but in radians that's pi over 3, so my answer to this equation is pi over 3. And if you think about substituting this in, the secant of pi over 3 is, and if I did that, would be 2. So when we're asked to solve these equations, look at the interval and draw your reference triangle in that quadrant, label the sides according to the ratio that you're given, and then determine the measure of the angle, being careful to use the angle measure units that the interval is given in. One other type of equation we might have you do is where we have an algebraic expression x squared and say equal to a trigonometric expression. And we don't have an algebraic way to do this yet, so we'll take this and use our calculator. So we'll enter this in as y1 on our calculator, enter this in as y2, and then we'll determine what the intersection point is. Now, if we look at this, you see we have the cosecant function here, and then here's the algebraic function. If you were to zoom in or zoom out on this, you would notice that there's actually a lot of intersection points. As you scroll up here, there's 2 more intersection points, and if you scroll up further, it intersects even further up. So in most cases, they'll ask you for the smallest, or the intersection point, or the smallest value of x which would work. So that would be the one that's the smallest point, or the lowest point, which would be this point right here. So you would then use your calculate button. You'd go and you'd want to find the intersection of those 2 points, and the intersection is somewhere between here and here. So I get an x value of 1.07, and so this would be the answer to my equation, 1.07. And again, that is arrived at by using my calculator. So those would be the two types of problems that we'll do in this lesson, aside from being able to graph those reciprocal functions and the tangent functions, and that will wrap this lesson up.